Good day, everyone. Good day. I just want to answer with you this question. So the question or the statement reads: excess of zinc metal was added to 200 centimeter cube of 2 mole, which is 2 molarity or concentration hydrochloric acid. Then the first one is write a balanced chemical equation for the reaction. Then B, calculate the number of moles of hydrogen gas produced in the reaction. Then we also have the volume of hydrogen gas produced at RTP, room temperature and pressure. Then what mass of zinc was used in the experiment. Okay, so now we'll start by answering the first question. So now the first one, we'll just write the balanced chemical equation. So what we have been given is zinc. So we'll say when the equation will be zinc, which is solid. This one will react in hydrochloric acid. So this is hydrochloric acid in aqueous, which will give us zinc chloride. So it's going to produce zinc chloride. It will be zinc chloride because zinc, the valence number for this one, it's 2, so it will be zinc chloride, which is also aqueous. Then plus hydrogen gas will be produced. So there is 2 hydrogen, so the gas like this will be produced. So this is the way the chemical equation. So now we need to balance this. We need to balance this chemical equation. So here we've got two hydrogen and we've got 2 chlorine. So there we've got 1 hydrogen and there 1 zinc. So chlorine it's 2. So we just add a 2 here. So here we add a 2. Okay, so now this equation is balanced. You answer like that, you get 2 marks. So question B, calculate the number of moles of hydrogen gas produced. So here you just need to use what you have been given. So what have we been given here? We have been given the hydrochloric acid, the volume of hydrochloric acid, and the concentration of hydrochloric acid. So let's change this into this meter cube. So changing that into this meter cube, we are saying that 1 this meter cube is equal to 1000 centimeter cube. Then x, so what we have here is 200 centimeter cube. Then whatever that happens, you say x is equal to 200 over 1000. So our answer is going to be 0. So this 0, so 0.2 decimeter cube. So now what we've calculated here, what we've done, we've just converted this volume into decimeter cube so that we can find the mole of hydrochloric acid. So now to find the mole of hydrochloric acid here, we'll say N, this is the formula of hydrochloric acid, H, then like this, is equal to So now this one, this the formula that we are going to use. No, not this one. So we'll change the formula that which we need to use on this one. On this one for us to calculate the moles. So the moles is going to be, okay, this one is equal to molarity, which is concentration, then times volume. So this is the formula that we are going to use. We are saying that this is molarity or the concentration, then this is what? The volume. So here the volume is this one, this meter, then the molarity is what? The 2m were given 2m, yeah. So just replace, so it will be n is equal to, where there is m, we say 2 times 0.2. So whatever happens when you multiply this, you get n is equal to 0.4 moles. So this 0.4 moles is for hydrochloric acid, for hydrochloric acid. So this is it. So now having this, we are going to use what? The proportion, because we have this equation here. We've got this equation. So here we've got this one is going, it will represent 2 more of what? Hydrochloric acid. So we'll say 2 more of hydrochloric acid. So this is more of hydrochloric acid, which is this hydrochloric acid. Let's say hydrochloric acid is equal to hydrogen. So there we've got 1 more of hydrogen. So here we'll say 1 more of what? Hydrogen. That's just hydrogen. Then what have we answered? We've answered the 0. So here 0.4 more, which is equal to, we don't know for the gas. So for a gas we don't know, then what happens? So we simply this times this times that. So we'll say this and this will get 2x is equal to 0.4. Then we reduce by 2, even there by 2. So this side and that side it goes. So we've got so here we've got this one into that. How many times? So I will write this side. So this into that we've got 0.2 moles. So this is the number of moles of hydrogen gas. So this is what we have found. So this is 0.2 moles of hydrogen gas. So therefore we write the answer here. So more of hydrogen, we are saying that N is equal to 0.2 moles of hydrogen gas, like this. So just put 2, then even that. So this is the answer. So if there is any addition, please you can leave your comment there. So now let's again find the volume of hydrogen gas produced at RTP. So for us to find the volume of hydrogen gas produced at RTP, we use this formula, which is N is equal to V then over V molar, the volume, the molar volume of a gas. So here we've got this is the molar volume of a gas, and this is the physical volume which we want to calculate. So here we have been given this one. So at RTP you need to know that the volume of this gas, gas is equal to 24 decimeter cube. So this is the volume of gas at RTP. So we'll just replace where there is N, we'll replace by what we have been given. So what have we been given? Where there is N, you replace by the number of moles of hydrogen. So the number of moles of hydrogen is this one, which is 0.2 is equal to, there we say V over this, you replace by 24. Yes. So when you multiply this and this, what do you get? So when you multiply this and this, so you say V is equal to 0.2 times 24. So 0.2 times 24. So we get, so V is equal to 4.8 decimeter cube. So this is the volume of this hydrogen gas at RTP. So now we proceed again to the last one. So the last one, we have been asked to find or to calculate the mass of zinc. The mass of zinc was used in the reaction. So we just want to find the mass of zinc that was used in this reaction. So now here to find the mass of zinc, since we know the moles of hydrochloric acid. So now this mole of hydrochloric acid again will give us the mole of zinc that was used. So we'll say the mole of hydrochloric acid, so hydrochloric acid here, then we will say this side we put zinc, so here it's more, and there it's also at more. So we put it's a ratio. So we are saying that from this equation we know here the coefficient of zinc is just 1, and the coefficient of hydrochloric acid there is what, 2. So we'll say, so having that information, we can say that 2 more of zinc of hydrochloric acid is equivalent to 1 more of zinc. Then again we calculated the moles of hydrochloric acid to be 0.4, which is also equivalent to X. So when we do our mathematics here, we find that this and this we are going to have 2x is equal to this, and this will have 0.4. So 2 over 2, there goes. So our x is equal to 0.2 more. So this is more of zinc which was used. So having this zinc, more of zinc which was used, then we can find the mass. We can find the mass of zinc. So now to find the mass of zinc, we'll use this formula, which is N, which is number of moles, is equal to mass over molar mass. So here the molar mass of zinc, we know zinc is 65. So zinc, the mass number of zinc there, it is just what, 65. So we use this 65 as our molar mass. Then we'll say where there is N, we'll replace by. So just make M subject of the formula. Just multiply this and this, will get mass is equal to N times molar mass. Okay, like that. Then we'll say this side you put 0.2 times 65. So what do we get when you multiply that? So 0.2 times 65. So we get 13 grams of zinc. So there is 13 grams of zinc. So 13 grams of zinc was used in the reaction. Thank you very much. If anything, please leave your comment and you share the same content to other people. Thank you very much.